Yes, sir.
Yeah. You can see the motion in straight line. Indeed, we are having the topic. We are having the topics. First, it is distance, displacement, and its applications. And its applications. Thereafter, we are having the uniform motion, non-uniform motion. Correspondingly, we are having the average speed, and then average velocity, and then instantaneous velocity. Right?
Okay, sir.
Fine.
Yes.
Okay, fine. And then next we are having the definition of velocity, acceleration. Velocity and then acceleration. Correspond to this, we are having the equations of motion. Equations of motion. And applications of equations of motion. Applications of equation of motion. And then motion under gravity. Motion under gravity and its applications. And finally, we are having the graphs. Okay, na?
Yes.
These are the topics we are having.
Okay, sir.
Okay. Okay, fine. Okay, na?
Yes, sir.
Fine. You can see out of these topics, okay, mostly every time in the NEET or in the JEE mains, okay, in anything, they are asking on the this one average speed or average velocity and instantaneous velocity.
Okay.
Some years they asked on the these equations of motion and its applications.
Okay, sir.
Okay. Recently, they're asking on the this one motion under gravity and graphs.
Okay, sir.
These are the important topics. Okay.
Yes.
Okay. Fine. Previously, in the JEE mains, what they asked it is they gave the graph of VT, velocity and time, and they asked about acceleration time graph. Okay.
Okay.
Fine. Sometimes they
Yes.
gave velocity and displacement graph and asked about acceleration and displacement or acceleration versus time.
Okay, sir.
Like that questions they asked. So we can also expect in the NEET also, we can expect. Okay.
Okay, sir.
Okay, fine. This session, it is complete 1.5 hours. It is on the quick revision on the motion straight line.
Okay, sir.
Tomorrow class will start problems.
Yes.
Okay. First it is displacement. First it is distance. And you can observe, in this, okay, and you can observe in this one, that is entire mechanics is divided into three parts. as number one, it is kinematics. Number one, it is kinematics. Okay. And number two, dynamics. And number three, it is heat and thermodynamics. Okay, na?
Yes, sir.
So entire mechanics, we are going to study the properties of object with reference to the applied force or without reference of applied force.
Okay.
Okay.
Yes, sir.
In kinematics, we are going to study with or without application. Kinematics, we are studying about without any external force or external aid. Without external aid, we are going to study the properties of object. Studying the properties of object. Okay. That means we'll consider the object is in motion. Then we used to find the properties. Okay, na? Fine, na?
Yeah.
Okay, fine. Okay, fine. So that means whether the object, how it is in motion, we don't worry or we don't take respect, irrespective of how much force is acting on the object. How much force is acting on the object, we are going to study the properties.
Okay, sir.
We are going to study the properties. Okay, na? Fine. Firstly, before going to see the this one, I'll consider first it is when we can say that object is at rest. Consider the Cartesian coordinate system. Cartesian coordinate system. Okay. In this
Yeah.
Cartesian coordinate system, let us consider a particle of mass m, which is at point A. With respect to origin, it is at a distance. It is at a distance. Let us consider this distance as r.
Yeah.
After a particular time, like 1 hour or 2 hours or 1 day, okay, anything, after a particular time, if the object stays at this position, then we can say that object is at rest. Okay.
Yes, sir.
That means if the object does not change its position, with respect to time, then we can say that object is at rest.
Yeah.
Okay, na?
Yeah.
Then we can say that object is at rest. Okay, na? Next,
Yeah.
similarly, motion. If object changes its position with respect to time, then we can say that object is in motion. Okay,
Yeah.
na? If object, the object changes its position with respect to time, then we can say that object is in motion. Okay, na? Is it fine?
Yeah. Yes, sir.
Okay, fine. Okay, fine. Next. Now we'll come to the distance. This distance we can indicate with S or D or X or Y. Okay.
Okay.
Okay, fine. Now let us consider 2 points, A and B. Okay. Let us consider 2 points. Particle is moving from A to B.
Yeah.
Okay, na? Particle is
Yes.
moving from A to B. And let us consider we are having the path as like this. Particle can move in any direction like this. Okay. Or like this. Right? So this is one in any path. I am
Yeah.
considering the path as 1, 2, 3.
Yes, sir.
Here I am considering path 1. Particle is moving from A to B in this path like this. So I can say that A is the initial position and B is the final position. Right?
Yes.
So this is the path length covered by particle from A to B.
Yeah.
So distance is defined as path length covered by particle okay, from initial position to final position, from initial position to final position,
Yeah.
right, can be called as distance, can be called as distance. Okay, fine. Suppose example, okay, approximately I can say distance between Hyderabad to Bangalore is 700 kilometers, right?
Yeah.
Fine. Can I say?
Yeah.
Okay, fine. So that means here Hyderabad it is my initial position.
Yeah.
Bangalore is my final position.
Yeah.
Okay, na? Okay, fine. So distance it is the path length covered by particle from initial position to final position. So I can say SI unit of distance is meter. In short, I'll write as M. And CGS unit of distance is centimeter. Okay, na?
Yeah.
Fine. Okay. And we know that relation between meter and centimeter it is 1 meter equal to 100 centimeters. Okay,
Yeah.
na? Okay, fine. That is the relation. Remember this one.
Yes.
Okay. Next, displacement. Next it is displacement. This displacement will indicate with R, small r. Or we can also indicate with S.
Okay.
Okay. Fine. Displacement, it is defined as shortest distance. It is the shortest distance traveled by the particle from initial position to final position. From initial position to final position. Okay, na? Can be called
Yeah.
as displacement. Can be called as displacement.
Yeah.
So, by definition, displacement means shortest distance.
Yes.
So, I can say that SI unit of displacement is same as like SI unit of distance. Okay, na? That is meter.
Yeah.
And CGS unit of displacement is same as like distance. That is centimeter.
Yes.
That is centimeter.
Yes, sir.
Okay, fine. Okay. And special unit of this distance or displacement. Special unit of displacement and distance is kilometer. Okay. From the prefixes, we know that 1 kilometer equal to 1000 meter. Okay,
Yeah.
na? Fine. Na?
Yes, sir.
Okay. 1 kilometer equal to 1000 meter.
Yes, sir.
Okay. Next one, it is applications. Applications of distance and displacement. Distance and displacement. Okay,
Yeah.
fine. First one, it is let us consider a particle is moving in a circular path of radius r. Okay, na?
Yes, sir.
This is my radius r. We are having a particle of mass m, which is at A.
Yeah.
Okay, completes one complete rotation. For one rotation, I need to find distance and displacement.
Yeah.
Okay, na?
Yes, sir.
Okay. Whenever it completes one rotation, distance, I can say that it is path length covered by particle. So, my path length, it is circumference of a circle,
Yeah.
right? Huh? So,
Yes.
circumference of a circle, I can say that it is 2 pi r.
Yeah.
Okay. Displacement. Displacement means, even you can see the definition of displacement, it is the shortest distance
Yeah.
traveled from initial position to final position, right?
Mm. Yes.
Now, in this case, initial position and final position are same.
Yes.
So, displacement will be 0.
Oh, okay. Yeah.
Okay. Since I can say initial position equal to final position, right?
Yeah.
Okay, fine. Next, second one, let us consider a particle is moving in the form of a semicircle. In the form of a semicircle. That is, particle moves from A to B. A to B. Such that O is the center. OA equal to radius and OB is also equal to radius, right?
Yeah.
So in this case, distance, same as like before, distance means it is path length from A to B.
Okay.
That is nothing but circumference of a semicircle.
Yeah.
That is nothing but pi r.
Yeah.
Okay, na? Is it fine?
Yeah.
Okay, fine. So displacement. Displacement. A is the initial position. B is the final position.
Yeah.
So final position minus initial position.
Yes.
Shortest distance means like this also it can move now. A to
Yeah.
O, to B.
Yeah. R.
Okay.
O to R.
AO plus OB. That
Yes,
is
sir.
nothing but 2R.
Yeah.
Fine. Next. Now, let us consider we are having a particle of mass m. Okay. It moves a distance of 3 centimeter and reaches to point P. And then it moves horizontal 4 meter. Now, in this case, I want to find what is the distance and displacement. Okay.
Yeah.
Distance, that is the path length covered by particle. That is nothing but AB plus BC, nothing but 7 meter. Okay,
Yeah.
na? Okay, fine. Next, displacement.
Sir, is it 3 centimeters and 4 meters?
Oh, sorry. 4 is also centimeters.
Okay.
Okay. 4 centimeter. So it will be 7 centimeter.
Yeah.
So displacement. Here, point A is the initial position. C is the final position.
Yes.
Right? So
Yes, sir.
initial position to final position means that is from A to C. By using Pythagoras theorem, I can say this is 5 centimeter.
Yeah.
So displacement it is 5 centimeter.
Yes, sir.
So I can say in this case, displacement is less than distance.
So
Okay, na?
always distance will be greater than displacement. No.
Huh? No, ma.
Always the no, sorry, distance will be greater than displacement. No.
Sometime it is equal. That
Okay.
case
Yeah.
also will get.
Yeah.
That case also will get. Okay.
Yes, sir.
Next, fourth case. If I am having a particle which is moving in the form of a square, in the form of a square, let us consider initially particle starts from A to B, and then B to C, C to D, and then D to A. Okay,
Yeah.
fine. Huh?
Yes, sir.
Now, it is having an side of a square as A. Now, I want to know the distance and displacement.
Okay.
Distance, that is the path length, nothing but perimeter of a square.
Yes, sir.
Perimeter of a square. Perimeter of a square is nothing but 4A. Okay.
Okay.
And then displacement. Displacement, here you can see A is the initial position. Whenever it completes one complete rotation.
Sir, why not S square, sir? Area.
That is area, na?
Huh.
That is
But
whenever you say area, okay, all this it will come. Distance, it is only path length only, na?
yes, sir.
It does not depend on the area, na?
Yeah. Okay.
Okay, fine. So displacement, initial position and final position are same.
Yeah.
So I can say it is 0.
Okay. Why,
Okay, na?
sir, can you explain again? Displacement right is
Here,
0.
particle moves from A
Hmm.
and reaches the final point as A only. That is,
Oh,
particle is moving from A to B, B to C, and then C to D, and finally D to A.
okay.
Right?
Yes, sir.
So, for one complete rotation, we are considering.
Okay, sir.
So, displacement will be 0.
Yeah.
For half rotation, okay? Half rotation means that is from A to C, right? From A to C,
Yeah.
fine. From A to C, what is the distance? That is A to
Mm,
B plus B to C, right?
yes, sir.
So displacement from A to C, displacement means that is along the diagonal.
Sir, I cannot see the down part.
Distance, can you see?
No, sir. I can only see two.
Okay. This one from A to C, can you see?
Yeah. Yeah.
Uh, so distance means that is AB plus BC,
Yeah.
right? Fine. Displacement means along the diagonal.
Yeah.
Okay, na? Okay, fine. So I can say distance equal to AB plus BC,
Yeah.
right? And displacement means that is nothing but AC.
Yeah.
Fine. Okay. How to find value of AC? AC. It is a diagonal, na? We are
Yeah.
having a right angle triangle APC.
Yes.
Apply
Yes.
Pythagoras theorem. Apply
Mm.
Pythagoras theorem. So AC, can I say root
Good.
2A?
Yeah. True. True.
So AC equal to root 2 times A. Okay, na?
Yeah.
Fine.
Yes.
Okay, fine. Now you can see, okay, root 2 times A. That is, I think, fourth one completed. Na? Next it is fifth one. Value of root 2, we can say it is 1.414,
Yeah.
right?
Yes.
So here also I can say displacement is less than distance.
Yeah.
Okay, na? Okay, fine. Next, you can see it is fifth one. Let us consider we are having Cartesian coordinate system. Initially, particle is at position x1 comma y1. x1 comma y1, right?
Yeah.
And after some time, particle moves to B along in this path. Along in this path. Okay. Point B is having coordinates x2 comma y2. x2 comma y2.
Yeah.
So in this case, I want to find distance and displacement.
Okay.
Okay, na?
Yes.
In this case, I want to know the distance and displacement. Distance. Distance between 2 points. I can say it is square root of x2 minus x1 whole square plus y2 minus y1 whole square.
Yeah.
Okay, na?
Yes.
Is it fine?
Yeah.
Okay, na?
Yes, sir.
Okay, fine. Okay, fine. So, displacement. Whatever the particle followed, A to B, this is the shortest distance, na?
Yeah.
This is the shortest distance. So, we can say displacement will also be square root of x2 minus x1 whole square plus y2 minus y1 whole square,
Yeah. Okay.
right?
Yeah.
Fine.
Yeah.
So, in this case, what I can say that it is displacement equal to distance,
Oh,
right?
okay.
Whenever the particle travels in a straight line, then we can say that distance equal to displacement,
Okay,
right?
sir.
So, on an average, okay, totally, all the cases, I can say displacement is less than or equal to distance,
Yeah.
or the ratio of displacement to the distance is less than or equal to 1.
Yeah.
Okay, na? Fine.
Yes, sir.
Okay, fine. That is what on the applications of distance and displacement.
Okay,
Okay.
sir.
Here we'll have afterwards sometime we'll have the direction. Like particle is moving towards north, okay, for with a velocity and for a time t. For a time t. Okay. And afterwards we need to find the direction of the particle. Direction of the particle. Right? Huh?
Yes, sir.
Okay. Uh, that direction, how we'll find, we'll discuss afterwards.
Okay.
Okay, na?
Yeah.
That also like northwest, how we'll calculate, or southeast, how we'll calculate. That also I'll discuss.
Okay. Okay, sir.
Okay, fine. Okay, na? Fine. Next it is uniform motion and non-uniform motion. Uniform motion. Okay. In short, we'll write as UM.
Yeah.
Uniform motion means if the particle travels equal distances in equal intervals of time. If the object travels equal distances, equal distances in equal intervals of time, intervals of time, then the motion is said to be uniform. Then the motion can be called as uniform motion. Okay, na?
Yes, sir.
Fine, na?
Yes, sir.
Okay, fine. That means mathematically I can write distance is proportional to time. Okay, na?
Yeah.
So, in order to remove proportionality, I'll keep a constant k. So, k equal to s by t. That is nothing but distance by time.
Yeah.
Okay, na? Okay. Distance by time, nothing but speed only, na?
Yeah.
Right? Huh? Speed will indicate with c. Speed will indicate with c. Okay.
Yeah.
So instead of k, we are writing as c. We are writing with c.
Okay, sir.
C equal to s by t.
Yeah.
Okay. So by using this, we can say SI unit of speed. SI unit of speed is meter per second,
Yeah.
and CGS unit of speed is centimeter per second. Right?
Yeah.
Okay. Next, it is non-uniform motion. Non-uniform motion. In short, we'll say it is NUM. Non-uniform motion. Non-uniform motion means that if the particle or object, if the object travels unequal distances, either in equal intervals of time, equal or unequal intervals of time. Okay, na? Intervals of time. Then we can say that it is non-uniform motion. Right? Huh? Fine. Huh? If the object travels unequal distances, either in equal or unequal intervals of time. Okay, na? That is if S is proportional to t power x, where x belongs to rational number, such that x is not equal to 1. Right? Huh? Fine. Huh? Okay. Is it okay? Okay, fine. Suppose x is rational number. Let us consider an example. S is proportional to t square. Okay. If time is increased by 2 times, then distance will be increased by 4 times. Can I say?
Yeah.
Increased by 4 times. Okay, like this. That means here distance will be either increases or decreases non-uniformly. Non-uniformly. Okay, because if x equal to 1, then it becomes as uniform motion.
Yeah.
Okay, na? Fine. So, correspond to this. Let us consider an automobile is moving on road. On road. Approximately, it is moving with the same constant velocity, same speed, right?
Yeah.
Then I can say that the automobile, it is in the uniform motion.
Yeah.
Okay. Suppose we are having a hill like this. Whenever a person is trekking, then we can say that while moving up, velocity will be less. While
Yeah.
coming down, velocity will be more, right?
Yeah.
So I can consider this type of motion can be called as non-uniform motion.
Yeah.
Non-uniform motion. Okay.
Okay.
Okay, fine. Non-uniform motion. So here, firstly, we are having the average speed. Average speed. That is nothing but we'll indicate with C average. Okay. Now, let us consider I'm having a particle of mass m, which is initial at point A. It is moving to point B. Point B. In between, we are having the intervals like C and then E. From A to C, particle is having a speed v1. Okay, na?
Yeah.
And C to E, particle is having a speed v2. And from E to B, particle is having a speed v3. And in the times t1, t2, t3. Okay.
Yeah.
Now I want to find what is the speed of the particle. Okay.
Yeah.
What is the original speed of the particle? In order to find the speed of a particle, okay, here what we are having that we'll find the mean value or average value between initial position to final position. Whenever we are having the speed of a particle is having more than one value, then we'll find the average value or mean value.
Okay.
There is a chapter in second year or class 12th. It is alternating current,
Yeah.
where we'll find the average value of current.
Okay.
That means here also in entire one complete cycle, we are having that current is having the different value.
Okay.
Alternatively, we will have minimum, maximum and minimum.
Okay.
Maximum and minimum. So in that case also we used to find the average value.
Okay.
Okay. So average speed. Generally speed means we can say it is distance by time.
Yeah.
Okay. So average speed means we can say it is total distance by total time. divided by total time. Total distance means from A to B. That is nothing but distance of AC plus CE plus EB by time taken, total time taken, T1 plus T2 plus T3. Okay, na?
Yeah.
Okay. Sometime, or we can say distance of AC as S1 and distance of CE as S2 and distance of EB as S3. So, C average, I can say that it is S1 plus S2 plus S3 by T1 plus T2 plus T3. Right?
Yeah.
Remember this formula.
Okay, sir.
C average. Okay,
Yeah.
fine. Suppose in entire interval, if I know only speed and time, then distance I can replace as V1 T1, distance equal to speed into time,
Yeah.
right?
Yeah.
Fine. So V1 T1. Similarly, in the second interval, V2 T2, and in the third interval, it is V3 T3 divided by total time, T1 plus T2 plus T3.
Okay.
Okay, na?
Yeah.
Is it fine? Okay, this is second formula. If I know distance and time only, sorry, distance and speed only.
Yeah.
So I'll replace time. We know that speed equal to distance by time, right?
Yeah.
So T1 I can replace as S1 by V1 plus S2 by V2 plus S3 by V3. Okay, na?
Yeah.
Okay, fine. So this is the third form. Suppose if they gave distance and time, I'll use the formula 1. If they gave speed and time, I'll use formula 2. If they gave distance and speed, I'll use formula 3. Okay, na?
Yeah.
Fine, na?
Yes, sir.
That is what on the average speed.
Okay.
Next, average velocity. Average velocity. Same as like before, we can say that average velocity that is V average is equal to total displacement by total time. Okay, na?
Yeah.
Total displacement by total time. If we are having two intervals, then I can write R1 plus R2 by T1 plus T2.
Mm. Yeah.
In the above example, we consider three intervals, right?
Yeah.
If I consider two intervals, okay? Suppose, let us consider example.
Sir, why did you take only two intervals?
uh, just assumption, ma.
Okay.
You can consider three or
Oh,
more, right?
yeah.
Let us consider an example or numerical, whatever it is. I think you can see the wall clock or wristwatch.
Yeah.
We'll have the numbers 12, 6, okay, 3, and then 9. Right?
Yeah.
In between, we are having the numbers. Right?
Yeah.
Now, suppose, let us consider minute hand. Minute hand. Okay. I can say 1 minute equal to 60 seconds. Right?
Hmm.
Suppose if radius of needle, I am considering, okay, this radius of needle as 1 centimeter. Okay.
Okay.
For simplicity of calculation, I consider r equal to 1 centimeter.
Yeah.
Okay.
Yeah.
Fine. So in this case, I want to find what is the average speed and what is the average velocity.
Okay.
Okay. Na? Whenever the minute hand completes one rotation, suppose let us consider the time it is 1 p.m. Okay. Whenever the minute hand completes one rotation, then it is 1 p.m. Right?
Yeah.
So average speed means total distance traveled. Whenever it completes one rotation, I can say it is distance. Total distance means 2 pi r.
Yeah.
By time. Time means 1 minute.
So, oh, sir, are we not taking in seconds?
Now I'll convert ma.
Okay.
2 pi. Radius it is we consider 1 centimeter. That is
Yeah.
10 power minus 2 meter by 60 seconds. That is nothing but pi by 30 into 10 power minus 2 meter per second. Or I can say pi by 30 centimeter per second.
Yeah.
Okay, na? Whenever
Yes.
it completes one rotation, what will be the displacement?
0.
0. So displacement is 0 means average velocity is 0, na?
Yeah.
Okay. Similarly, we can consider our hand. Okay. Let us consider time it is 3 p.m. to 4 p.m. Right?
Yeah.
That means suppose initially time is 3 p.m.
Yeah.
When it will complete 4, 5, 6, and so on like this. Right?
Yeah.
When our hand will complete one rotation. Okay. That means average speed equal to 2 pi r, same. By time means 1 hour. Okay.
Yeah.
2 pi centimeters by 1 hour means 60 minutes. And 1 minute equal to 60 seconds. Right? Is it fine? This is for 1 hour. Okay. Like that, it is rotating for 24 hours now. After a time of 24 hours, it is repeating now.
Yeah.
Later.
Yes, sir.
Okay, fine. Like this, we'll calculate on average speed and average velocity.
Okay, sir.
Okay. Suppose let
Yes.
us consider here it is Hyderabad.
Yeah.
Here it is, let us consider Mumbai. Okay. Okay. From Hyderabad to Mumbai, if you ask me distance, approximately. Okay. If you ask me distance, approximately around, I can say around 800 kilometers or 1000 kilometers. Right?
Yeah.
Right? Okay. So more precisely, I will ask whether it is road distance or rail distance or it is by air. Flight distance will be less,
Yeah.
right? So this road distance, I can say it is distance. This rail or air, I can say displacement.
Yeah.
So correspondingly, we'll have velocity,
We'll have no, sir.
right?
Yeah.
We'll have velocity.
Yeah.
So that means in uniform motion, average, since distance equal to displacement, I can say average speed equal to average displacement. Sorry, average velocity.
Yeah.
Since distance equal to displacement, so average speed equal to average velocity.
Yeah.
Whereas in non-uniform motion, displacement and distance are different. So I can say average speed is not equal to average velocity. Okay, na?
Okay, sir.
Fine, na?
Yeah.
Next, instantaneous velocity. Instantaneous velocity. Let us consider particle is moving from, okay, particle starts from A, okay, and reaches to the point B. In between, we are having the points C, D, E. Okay. Here, particle starts with a speed V1, and here it is V2. And it takes a time of 20 seconds. Okay, na? Fine, na?
Yeah.
Now, I want to find what will be the velocity at C or at a time of at t equal to 4 seconds. That is, instantaneous velocity means it is the velocity of the particle or object at a particular instant of position or particular instant of time,
Yeah.
such that the displacement will vary as a function of time.
Okay.
Okay. So velocity means we can say rate of change of displacement.
Yeah.
Okay, na?
Yes.
Suppose, for example, if displacement is varying as a function of time as t cube minus 2t square plus 5t minus 10 meters. Find instantaneous velocity at t equal to 2 seconds. t equal to 2 seconds. We need to find what is the instantaneous velocity.
Okay.
So first, to find instantaneous velocity, we'll differentiate it. Okay.
Yeah.
After differentiating it, then I will substitute instead of time as 2 seconds. That is d by dt of t cube minus 2t square plus 5t minus 10. Okay, na?
Yeah.
Fine, na?
Yes.
So upon differentiation, we'll get as 3t square minus 4t plus 5. Because 10 is a constant, d by dt of
Yeah.
constant is 0.
Yes.
Okay, now I'll substitute. I need to find velocity at t equal to 2 seconds.
So why not
So,
just direct substitute it? We should differentiate and then substitute the value.
because here displacement is varying. Na?
Okay.
Okay. After
Yeah.
differentiation, we need to substitute.
Okay.
3 into 2 square minus 4 into 2 plus 5. So it will be 12 minus 8 plus 5. Around 9 meter per second. Right?
Yeah.
Okay. Similarly, I can find at 4 seconds or 8 seconds. Right?
Yeah.
At any time from 0 to 20 second, I can find now.
Okay.
Right? That means the total time it is 20 seconds. From 0
Oh.
to 20 second, I can find.
Mm.
Right?
Yes, sir.
Is it fine?
Yes. Yes.
Okay, fine. That like this, we'll find the instantaneous velocity.
Okay, sir. So, till when will you take the class?
Another half an hour or 15 minutes. Or
Okay.
tomorrow we'll continue.
No, sir, your wish. If you are taking till 7:30, it's fine.
Up to this one, it is over. Now it is our main part. Ma. If you see the flow chart, up to here
Yeah.
completed. Next it is velocity and acceleration. Thereafter, equations of motion.
Okay.
Thereafter, we are having the equations of motion. Okay. I think we started class around 6 p.m. Na?
Yeah, 5:56 I joined.
Yeah. Velocity will indicate with V. Ma.
Hmm.
Velocity is defined as rate of change of displacement. That is nothing but dr by dt. Okay.
Okay.
Always velocity means rate of change of displacement.
So,
If
instantaneous velocity, no?
no, normal velocity. Ma.
Normal
Instantaneous
velocity.
velocity means I'll keep VIN.
Yeah. Okay. Okay, sir.
Velocity, we can say rate of change of displacement. That is
Yeah.
final position minus initial position by final time minus initial time. Okay, na? If initial position is equal to 0 and initial time equal to 0, then I can say velocity equal to displacement by time. Okay, na?
Yeah.
Only in this case only we can say. This is exceptional case.
Okay.
Every time we'll say it is rate of change of displacement only.
Okay. Okay, sir.
Rate of change of displacement only. Okay. So SI unit of velocity is meter per second and TGS unit of velocity is centimeter per second. Okay, na?
Yeah.
Special unit of velocity. Special unit of velocity is kilometer per hour. Right?
Okay.
Okay. Now we'll see the how to convert kilometer per hour to meter per second.
Yeah.
Convert kilometer per hour to meter per second. So it is 1 kilometer per hour. I need to convert into meter per second. 1 kilometer means, can I write as 1000 meter?
Okay.
Right? Okay. 1 hour, I can write as 1 hour equal to 60 minutes and 1 minute equal to 60 seconds. So around it is 3600 seconds.
Yeah.
Fine. So
Yes,
upon
sir.
calculation, we'll get as 1 kilometer per hour equal to 5 by 18 meter per second.
Yeah.
Okay. For example, 72 kilometer per hour convert into meter per second. Okay.
Yeah.
That means 72 kilometer per hour equal to 5 by 18 into 72 meter per
Yeah.
second.
Yeah.
That is nothing but 20 meter per second.
Yeah.
Okay, na?
Yes.
Is it fine?
Yes.
Okay. Next, similarly, we are having acceleration. We are having acceleration. Acceleration is defined as okay, acceleration equal to dv by dt.
Yeah.
That is nothing but rate of change of velocity. Okay. So I
Yeah.
can say final velocity minus initial velocity by final time minus initial time.
Yeah.
Final velocity which will indicate with v and initial velocity which will indicate with u.
Yeah.
Okay, na?
Yes.
So by definition I can say a equal to v minus u by t because initial time will be 0.
Yeah.
Okay, na?
Yes, sir.
Is it fine?
Yeah.
Okay, fine. Now you can see a equal to v minus u by t. So SI unit of acceleration is meter per second square because velocity means meter per second
Yeah.
divided by second. Divided by second.
Yes.
So it is meter per second square and CGS unit of acceleration will be centimeter per second square.
Yeah.
Right?
Yes.
And then next, negative acceleration can be called as negative acceleration can be called as deceleration or retardation. Deceleration or retardation. Okay, na?
Yeah.
Okay, fine. Suppose let us consider we are having a graph. On x-axis it is time and on y-axis it is velocity. If a particle is moving straight, okay, and then moves with constant velocity. This is up to time t1 and here it is t2. Okay. From
Okay.
0 to t1, particle moves with an straight line.
Yeah.
Right? And from t1 to t2, particle moves with constant velocity. Now I need to find acceleration versus time.
Okay.
Okay, na?
Yes, sir. So,
So
so once can you move to the previous page?
I will share document. That's why. Okay.
Okay, sir.
Please try to be patient till the graphs.
Yeah,
So that
okay, sir.
what happens, whatever I'm writing now, this entire document, I will
Yeah.
share to you. Okay.
Okay.
Up to your
Okay.
exam, it will be like quick revision.
Yeah.
Right. Instead of breaking the class, okay, what I'm trying to do it is, uh, till graphs will complete it today.
Okay, sir. Okay.
If you have here and there any doubts, we'll see tomorrow.
Okay. Okay, sir. No problem.
One complete document on motion straight line.
Okay. Okay, sir.
Uh, from 0 to t1, you can see particle is moving straight line.
Yeah.
So that means in this path, I can say that velocity is directly proportional to time. Can I say?
Yeah.
So from 0 to t1, from 0 to t1, I can say velocity equal to some constant into t, right?
Yeah.
Okay. During this time, acceleration I want to find. Acceleration means dv by dt. That is d by dt of kt.
Yeah.
So acceleration is constant. Okay, na?
Yeah.
And from t1 to t2, t1 to t2, you can see, okay, velocity is constant.
Yeah.
When velocity is constant, what will be the acceleration? That is dv by dt, d by dt of constant. What is the value of d by dt of constant?
Constant only. Oh,
Zero,
0. Yeah.
right?
Yeah.
So if I draw the acceleration versus time graph from 0 to t1, acceleration is constant, right? That means
Yeah.
like this. Up to here it is t1. And then t1 to t2, acceleration is 0. Acceleration is 0 means this one only, na?
Yeah.
And like this, they are asking questions, right?
Okay. Sir, I'll try this example. If I didn't get, will you explain me again tomorrow?
Yeah, yeah.
Okay.
I will tell because tomorrow and day after tomorrow, 2 days or 3 days, we'll discuss problems only.
Okay, sir.
Okay.
Yeah.
Mostly 3 to 5 hours. We'll discuss problems on motion in straight line.
Okay.
After that, next we'll go to next chapter.
Okay, sir.
Okay, fine. Next one it is after the velocity, time, and acceleration time graph, we are having the equations of motion. Okay. Now, people derive for the whenever the particle is in whenever the particle is in motion, then we want to find the properties of particle like velocity, acceleration, and then displacement. Okay. Here we are considering particle, let particle is moving in straight line. Is
Okay.
moving in straight line with constant acceleration. Okay. With
Yeah.
constant acceleration. Okay, na?
Yeah. Yes, sir.
Fine. Na?
Yeah.
Okay. That means acceleration equal to constant. Some value is there. This constant belongs to set of rational numbers. Maybe positive value or it may be negative value. Anything.
Okay.
Okay. Okay. Soon after the particle started, we'll have the initial velocity. Before reaching the final point, we are having the final velocity. Takes a time t. Okay. So, first equation of motion it is V equal to U plus at. Second one it is S equal to ut plus half at square. Right?
Yeah.
S it is the, actually it should be displacement ma. Since it is moving a straight line, we can say distance equal to displacement.
Okay, sir.
Okay. Actually it should be, we'll consider displacement.
Yeah.
Number 3 it is V square minus U square equal to 2AS. Okay. Fine. Na?
Yeah.
Ah, fine. These three are the basic equations. Now we are having the applications of equation of motion.
Okay.
Applications of average speed and equations of motion. Okay, na?
Yeah.
Fine. Na?
Yeah.
Okay. 1 minute, ma. Once see this one. Okay. Once see
Okay.
this one. Okay. Once go through this one. Okay.
Okay.
1 minute. Hello.
Yeah, yes, sir.
In these applications of motion, first we'll complete applications of average speed.
Sir, for equations of motion, I wrote only till second equation.
Third equation, v square
Mm.
minus u square equal to s.
Yeah. Yes, sir. Done.
Fine. Next, first application on the average speed. If the object travels equal distances, okay,
Yeah.
or if the object travels half of the distance, half of the total distance, half of the total distance, total distance in a time t1, in a time t1, okay,
Yeah.
with speed v1, and the remaining distance, and the remaining distance in a time t2 with speed v2. Then find average speed. Okay, na?
Yeah.
So average speed equal to total distance by total time. That is, suppose A to B, it is the total distance. Let us consider it as S. We are having a point C. It is half of the distance, S by 2. Moves with a speed V1.
Yeah.
So remaining speed, it is V2. So I can say the total distance means S by 2 plus S by 2. They gave here V1 and V2 now.
Yeah.
So I'll write T1 equal to S by 2 by V1 and T2 equal to S by 2 by V2. So that is nothing but S by 2 V1 plus S by 2 V2.
Yeah.
Right? In the denominator, take S by 2 common. So upon calculation, we'll get it as 2 V1 V2 by V1 plus V2.
Yeah.
Right?
Yeah.
Fine. Similarly, I'll consider if the object travels with a speed V1, if the object travels with a speed V1 or U for, for half of the time taken, half of the time taken, and the remaining time travels with a speed, travels with a speed V2 or V, V2 or V. Then determine average velocity or average speed. Right?
Oh.
Fine. That means we are having the particle of mass m, it is at A, moves to B. The total time it is T. Okay. Here we are
Yeah.
having a point C. From A to C, it takes a time T by 2 and moves with a speed as V1, that is U. Right?
Yeah.
For the remaining time, it will move with a speed V2 or V. So here I know speed and time now. So I am using the principle V1 T1 plus V2 T2.
It's V1 by U or V1 by V?
No, it is R.
Okay.
We can indicate with V1 or U. Right?
Okay. Yes, sir.
So T1, it is T by 2. V2, it is V. Okay, na?
Yeah.
So in this case, average speed it is V plus U by 2. Right?
Yeah.
So that means whenever the object travels in equal time intervals, average speed is V plus U by 2.
Yeah.
If
Okay,
it
sir.
travels equal distance, it is 2 V1 V2 by V1 plus V2.
Okay, sir.
Right?
Yeah.
Fine. Okay. Now, okay, na?
Yeah.
Fine, na? Up to here, remember, ma.
Okay, sir.
Notes is also over. Okay.
Yeah.
I'll share the notes. Tomorrow, these applications are there, and I think it is. Equations of motion is completed. Motion and gravity and graphs, na?
Yeah.
Okay.
Okay, sir.
These three topics only, na? Another, I think 30 minutes it will complete tomorrow. Okay.
Okay, sir.
And
Okay, sir.
thereafter we'll do problems on
Okay,
these
sir.
equations of motion.
Yeah. Okay, sir.
Okay, na?
Yeah.
Uh,
Okay, sir. Thank you so
okay,
much.
fine. Tomorrow we'll meet.
Yes, sir.